Good afternoon, everyone. I'm very honored to have the opportunity to share our company's slope radar products and solutions with you today. I am Tianqi from Suzhou Rico Sensor Company. The title of today's report is Application of Slope Radar in Open Pit Mines. My report today is divided into three parts: company profile, slope deformation monitoring radar product introduction, and some application cases of this product in open pit mines. The company is supported by a team including 2 academicians of China Engineering Academy. Also, they are from Beijing Institute of Technology. The team has developed and produced civilian radar products for more than 10 years. Currently, our main products are slope deformation monitoring radars and airport runway FOD monitoring radars and other civilian radars. The company has an R&D center in Beijing and a production base and a microwave laboratory in Suzhou. We're expanding into the international market, and IT Experts is our exclusive agent partner in Mongolia. Now let's look at the second part. Okay, the first question is, what is slope radar? In open pit mines, slope radar is a device that measures the surface deformation of slopes. How slope radar works? Generally, the slope radar working process is divided into 5 steps. Step 1. The radar continuously scans the slope surface at a fixed period and obtains radar images one by one. During this process, we will continue to obtain radar image like below. This is a radar image. We can see some details like this in the image. Step 2. The radar finds the PS points in the image, and then we will make some interference processing, and then we can calculate all the deformation value of the entire slope surface. Okay, what is the PS point? We can think of it this way. 1 PS point is a pixel in the image. In this image, total pixels would be about 1 million. It's a quite big amount. After this step, we can obtain the deformation data of all pixels on the entire slope. Step 3. After step 2, we have deformation data of all pixels. And now, we can overlay the deformation results on the GIS map. Here is a GIS map. We can get very intuitive deformation result. Different deformation values are represented by different colors. For example, the green means that the deformation value is around 0. If you look carefully, you will find some other colored area among green areas. Here are some red point. Here's a blue. Step 4, we can select the area of interest on the map, like this. And the deformation curve of the area over time will be displayed. Okay. Step 5. This is the final task of the slope radar. The final task is to generate alarms. When certain factors that may trigger an alarm occur, in this case, we can see this part. The deformation is getting faster, so radar will send the alarm. Alarm can be sent in multiple ways, like buzzer, text message, email, screen flickering. Okay, so far, the typical process of slope radar has been described. There are some characteristics that differentiate slope radar from traditional monitoring methods like Genesis or total station. First, non-contact. Second, high accuracy. Accuracy would be up to 0.1 millimeter. Third, all day, all weather. Fourth, large scale. So you can see, slope radar is a very good choice for open pit mine. Next, I will introduce our slope radar products. Before I introduce our company's products in detail, please allow me to introduce a brief history of slope radar at first. Left part, this part of radar is collectively called mechanical scanning slope radar. This one is rail aperture radar. This radar has been around for more than 20 years and is a relatively traditional category of radar. It is very slow, expensive. These two, they are density aperture radar. They have been around for more than 10 years. In 2014, China's first slope deformation monitoring radar was developed by our team. We call it rail-mounted radar. This radar will move back and forth on this rail. And this is another type. We call it rotary type. When it works, the radar antenna rotates. These two density aperture radar are more cheap and more fast than this one. And this one, it is second generation slope radar. It does not have any mechanical structure and avoids various mechanical failures. It uses phased array technology, which can make measurements faster and more reliable. This is more suitable for working in harsh environments. In 2019, the world's first phased array electronic scanning slope deformation monitoring radar, it's quite a long name, was developed by our team. Okay. This is our product family, including rail-mounted, rotary, and of course, electronic scanning type. The latest type. Here we have some parameters summary of three radars. All these parameters define the distance, range, data point cloud density, and accuracy when slope radar works. These radars can complete monitoring tasks in mine very well. There is not much difference between their parameters. They have similar range, they have similar resolution, that is, similar amount of pixels. However, electronic radar is now our flagship product. Why? Because it is more fast, more reliable, very suitable for open pit mine. This is an explanation of the principles of phased array technology. Due to time constraints, I will not go into details. This is a typical scenario where the entire radar system is applied in open pit mine. On the edge of the pit, we can set up a chamber or a trailer and place the radar inside. In the monitoring center, we can set up the server to run monitoring software platform. The connection between the radar and the server can be cable or wireless network. So, what function does the monitoring software platform have? It has two major functions. First, as we said before, it can display the deformation results in 3 dimensions. It's good for us to discover the deformation area more intuitively. The second one is the early warning algorithm. Generally speaking, slope radar uses the threshold method. When the deformation value, speed, and the acceleration exceed our alarm threshold, an alarm is generated. We did further work and introduced other algorithms, including tangent angle method and AI algorithms, and dynamically adjusted the weight of each algorithm to select the most suitable early warning algorithm for the current slope. So, although it seems a little bit complicated, but after our applications, we found that it is smarter and more accurate. Here we have some other functions. The platform can integrate and display the measurement results of multiple sensors, like GNSS or weather station. We can see some point. This is some other sensors data. This feature is called zoom in. When an alarm occurs in a certain area, we will have a camera that can quickly focus on the alarm area, take photos and videos in this area. In the last part, I will share a few cases. So far, we have more than 100 cases, which are distributed in China, Mongolia, Russia, and Africa. This is a case from Mongolia that I will explain it to let you understand how slope reader works in mines. The mine is invested by China and is located in eastern Mongolia. This is the basic situation of the project. We have a radar installed next to the pit and the server placed in the monitoring center. The radar and the server communicate using 4G. One day last summer, the radar alerted. At this time, the early warning platform sent a level 3 yellow warning message. You can see how adaptive alerting works. We have multiple algorithms that alert at the same time. We have 1, 2, 3, 4, 5, 6 methods. The alert levels are different and they have different weights. Finally, we use the adaptive algorithm to give a final alert level, a yellow warning. Here is the information. The deformation of the east slope monitoring area reached 212.5 millimeter within 24 hours. The coordinates of the early warning point are this. Okay. Then the mine staff checked the deformation curve in the alarm and found that there was indeed a sudden change. Here curves. When the worker at the mine went to the slope according to the alarm coordinates, they found obvious cracks on the slope step. Okay, can see some cracks. Based on this situation, the mine decided to evacuate nearby mining machinery and staff. An hour later, the alert was further upgraded to an orange alert. That evening, we provided a monitoring report. This report is automatically generated by the platform. Okay, this is the process of early warning and triggering related processing by slope radar in the mine. Here we have some other cases in mine. Okay, that's all. Thank you for listening.